How does neuroimaging show brain plasticity? Have you ever wondered how our brains adapt and change over time? Neuroimaging plays a key role in revealing this fascinating ability known as brain plasticity. Brain plasticity refers to the brain's capacity to reorganize itself by forming new neural connections or modifying existing ones. This adaptability is crucial for learning, recovery from injury, and even aging. Neuroimaging techniques allow researchers to capture changes in brain structure, function, and connectivity. These changes occur as the brain responds to experiences, learning, or recovery from injury. One common method used is functional magnetic resonance imaging, which measures brain activity by detecting changes in blood flow. When a specific brain region becomes more active, it requires more blood, and this increase can be observed through neuroimaging. For example, during training or learning a new skill, certain areas of the brain show increased activity. This indicates functional plasticity, meaning that the brain is adapting to support new tasks. Another method, resting state functional magnetic resonance imaging, records spontaneous brain activity when a person is not engaged in a specific task. This technique reveals how different brain regions communicate and coordinate, showing how networks reorganize with experience. Structural magnetic resonance imaging can also provide insights into brain plasticity. It measures changes in gray matter volume or white matter integrity. For instance, improvements in white matter pathways indicate better communication between different brain areas, which can occur after learning or rehabilitation. Changes in myelination, the process of forming a protective sheath around nerve fibers, can also be observed through specific imaging techniques. More advanced neuroimaging methods, like positron emission tomography, estimate synaptic density or neurotransmitter levels. These insights help researchers understand the molecular basis of brain plasticity. They reveal how synapses, the contact points between neurons, are formed or pruned during critical periods of development or in response to experiences. Neuroimaging also highlights plasticity related to aging and cognitive training. Studies show that targeted cognitive training can reverse age-related declines by increasing blood flow and strengthening connections within key brain networks. These changes correspond to improved cognitive performance, showcasing the brain's ability to adapt even as we age. In clinical settings, neuroimaging tracks plasticity during recovery from brain injury or neurological disorders. This information guides rehabilitation strategies by identifying which brain regions are reorganizing. Personalized interventions can then be developed to support functional recovery. Overall, neuroimaging provides a window into brain plasticity by mapping dynamic changes in brain activity, network connectivity, and structural integrity. This knowledge is essential for understanding how our brains adapt throughout life and for developing applications that support brain health and cognitive function.